All right, what I'm going to do for this problem is I'm going to talk through parts B and C, focus in on parts B and C, and then I'm going to show you the work that they want for the whole question. So on part B, we have our null and alternative here. So because the population standard deviation is 15, they gave you for free that the standard deviation of the sampling distribution would be sigma divided by square root of n. So 15 divided by square root of 100 is 1.5. Okay, so here's what our distribution looks like. I'll keep my drawings up here. Mean at 122. Standard deviation at 1.5. So here's what that looks like. Two standard deviations along either side. So that's what the distribution looks like. Approximately normal, there's your mean, there's your standard deviation. And the question is asking, what would let us reject the null hypothesis at an alpha level of 0.05? So we're looking at the threshold that we would want to reject our null hypothesis. Well, that means that we want, since our alternative is that our mean is greater than 122, then we want to know the values out to the right. So we want a right tail so that the area is 0.05, which means when we're putting, so since we want a percentage, or we have the area, that's going to be an inverse norm. So we are going to do inverse norm of, since the right tail is 0.05, that means the area we want to the left is all the rest of it, which is 0.95. 0.95 is what you put in for your inverse norm, which is going to give you 1.645, somewhere around there. So that is my z-score for this value. And anything that's to the right of that value means I'm going to reject the null hypothesis. So we're figuring out what that value is. So that 1.645 equals value minus mean over standard deviation. And it gave us the mean and standard deviation. And so we're just trying to solve for that value. So multiply both sides by 1.5. And then we're going to add 122, etc. And when we do that, we should get our value to be around 124. I'll put more decimal places. There. So that is our threshold as to where this value is up here. Anything to the right of the 124.4675, and we reject the null hypothesis and conclude our alternative. So that is part B. Now what part C says is that the actual mean is 125, not the hypothesized value of 122. So I told you this question was about power, so here is our proclamation on high. Hey, the mean is 125. Mean is actually 125. So that means that that's the mean we should be using, and we're asking what is the probability that the null hypothesis gets rejected? Well, we just said the null hypothesis is going to get rejected when I get above this value. So I want the probability that x is greater than the 124.4675, given that the mean is actually 125. So instead of what I thought the distribution looked like, the distribution actually looks like this. It's centered at 125 instead. So that's my new mean. Standard deviation is still 15 over the square root of 100. So standard deviation stays the same, but the mean is now 125. So my z-score formula becomes value minus my mean of that I know now is 125 over my standard deviation, which is 1.5. So from here, you can do your normal CDF. My lower is that 124.4675. My upper is a really big number, mean standard deviation. And when I do that, that's going to give me a z-score of negative 0.355. And the probability that I'm bigger than that is about 0.64. So that's the calculation process that they're looking for in parts B and C. So what we just found was this area, this threshold that I actually reject the null hypothesis now that I know what the distribution actually looks like. And that probability that I just found is what power is. So part D, what statistical term is used is power. So now let me show what the entire problem's answers look like. Part A asked about type 2 error. It's leading you to power because power is 1 minus probability of type 2 error. Type 2 error occurs when the alternative is true, but the null hypothesis is not rejected, so failing to reject incorrectly. In this situation, that would happen if we don't conclude the alternative. We don't conclude that the mean blood pressure is greater than 122, when in fact it actually is greater. So not concluding that the mean is greater when it actually is. In other words, a type 2 error would happen if the mean blood pressure is higher, but the test does not conclude that it is higher. That's type 2 error. Your description of type 2 should not say the null hypothesis. It shouldn't say anything about the mean equaling 122. It should all be about the alternative, not concluding that the mean is greater than 122 when it actually is. Part B, we showed this process, and then that gives me my threshold for part C, which we calculated that we were above that threshold if the mean were actually 125. We said the power is what it was called. And then part E was asking if we change the sample size, how is that going to affect power? Well, we talked about how if the sample size is going to be increased, then the probability of rejecting a null hypothesis there will be higher. Increasing sample size also increases power. Rejection region will still be there, but the sampling distribution will have a smaller standard deviation. So smaller spread in this actual distribution, it's going to mean that we are going to reject more often when we are supposed to. So power goes up because sample size goes up. So that is the process and steps for that last question. Again, that's a pretty technical question 6. Just keep in mind that not all the question 6s are that hard, but that kind of walks you through the process of power and how it gets calculated.